Alright, welcome to Geometry. This is unit review for the first unit, Intro to Geometry. I'm going to start off with the first standard, which is actually GCOA1. So there's actually several GCOs, ones, but this one's going to be part A. So I'm going to do this, and I'm going to do it the same way I'm actually teaching it in class. So for this right here, it says use the figure at the right. Assume that lines look parallel, are parallel. Lines that look perpendicular are perpendicular. So parallel lines are basically the lines going in the same direction. Perpendicular lines are lines that are intersecting. So any of the ones touching here are actually all touching at a right angle. So that's what that means for that. So a couple of these things I'm going to go through. So I'm going to start with on the bottom one. Okay, the bottom one actually says name a pair of skew segments. So if I'm going to name a pair of skew segments, I'm going to start somewhere. So whenever you do this, they don't actually give you a place to start at, so you just pick one. So what I'm going to do is I'm going to start and I'm going to pick one. So I'm going to pick EA, just because. So I'm going to start off with EA. And then, okay, so for definition of skew is that they are not parallel and they're not perpendicular. So I'm going to eliminate all the ones that are going to be parallel to EA. So I'm going to use a different color right here, and I'm going to eliminate those as part of what it cannot be for skew. But the first thing right here is name a pair of parallel segments. Going the same direction would be an FB, a GC, and a DH. So for a parallel line segment, I would start with my EA, and parallel to EA is going to be any one of the ones that I just colored right there, going in the same direction, would be a FB. Okay, so now the next one right here says perpendicular. So with definition of skew is that it cannot be parallel and it cannot be perpendicular. So in my very simplified form, it can't go in the same direction and it cannot touch, because all the ones here touching are all touching at right angles. So for right here, so for this one right here for perpendicular, I'm going to go with all the ones that are touching my EA. So AD, EH, FE, and AB. So any one of those. So if I start out with EA, any of the ones touching EA like that are going to be perpendicular. So I have DA, EH, EF, and AB. So I just need to pick one of them that I had with EA. So I'm going to say EH are going to be perpendicular here. Now the next part is skew. So I've eliminated what it cannot be. So whatever's going to be left is going to be what it can be. So for this one, what it can be is EA is going to be skewed to any of the lines that I did not color. So these are the ones that are left over that they are going to be skew. So it would be HG, GF, CB, or DC. So I'm going to go ahead and I'm just going to say HG for this one. But any of those lines that are not colored are skew to this one. So whenever I'm writing my answer, I always have to start with my first one that I started off with, and skew to that one would be any of the ones left over. So like I said, this one had a bunch that were perpendicular, and this one had a bunch that were parallel. Alright, so let's keep moving on. So for the next one right here, it says use the diagram to the right to answer the following questions. Now these ones right here are kind of special because you're going to have more than one right answer. So even though that if I did not actually use yours, doesn't mean it's going to be wrong. But I'm just giving you an example of what it would be for this. So name a line, linear pair. So a linear pair is two lines that are adjacent to each other that add up to 180. So I would say like a LRP. So that's going to be angle R in between L and P. So angle LRP. So LRP would be here. So Let's see if I have my pencil for this one right here. So I can erase this. All right, L, R, P. So now I need a pair of angles that are touching this one that are going to add up to 180. So to complete this, I'm going to go all the way this way. You could have went all the way this way, okay? So now I'm going to say that it's going to be this side right here is L, R, M. So from here to here, all that's going to make 180. So I have my angle L, R, M. So it's angle R between L and M. So that's one way to read that. Actually, that's probably the best way to read it. Now the next thing, name two complementary angles. Now complementary angles add up to 90. So for this one right here, I have a 90 on this side, but then if this is straight line PM, that means that there's going to be 90 on the other side also. That's one of those rules that go along with this. So that also has to be 90 on this side. So that means that the two angles that would add up to 90 would be in between here and here. So that would be angle R in between O and N. So that's going to be O, R, N. So it's angle R in between O and N from here to here. And angle N, R, M. So it is angle R between N and M, just like that. For this diagram, that's the only right angle we have in here, though. That will be complementary. Okay, name two supplementary angles. Now, supplementary is kind of like a linear pair. They add up to 180. When I'm dealing with common vertexes, like I have right here, all of them have the same vertex, you know, a supplementary will also be a linear pair. So they're going to be the same, but just for the sake of, I'm going to use a different one right here. So I'm going to say, instead, I'm going to say this one right here. So let's go with here. So it's going to be MRN. So angle MRN. Okay, and the other side to complete it to be 180 would be from here to here. So it's going to be all of this. So here's my straight line right here. My straight line would be M to P through here. So MRN and NRP. For that one right there. And yes, that is a little sushi I have for an eraser. Through letter E, or I'm sorry, D. Adjacent angles. So adjacent means next to. So it's going to be two angles that are next to each other, do not overlap, that share a common vertex. So all of them here actually share a common vertex. So I could use any of the angles that are actually next to each other and share a side. So let's take a look. So I'm going to go with a, let's say NRO. This one's going to have a whole bunch of different ones. Angle NRO. That's going to be angle R in between N and O. So next to each other. So I'm going to use a next to each other. So I'm going to use this one right here. So NRM. So angle NRM. Okay, so now for this one, if you notice right here, here's one, and then here's the other. So they're next to each other, common vertex, they share the common side. So, and they don't overlap. So that's going to be the adjacent angles. Now, the next one is going to be right here. So angle E, or I'm sorry, letter E. So for letter E here, name a pair of vertical angles. So vertical angles, if you recall, are angles that together form an X. So what I'm going to do is I'm going to sketch first. I have a straight line there, and I have a straight line there. So I'm using the straight lines first so I do not confuse it. So I have the straight lines. So I'm going to use this angle here. So they're opposite sides of the x. So if these angles back up to each other like they do here, or if you want to use these ones right here, it's the same thing. But I'm going to use these. So they back up to each other and together form an x. So this is going to be angle R in between L and P. Angle R between L and P. So that's going to be L, R, P. And angle. So the other side is going to be an MRN. So MRN. Okay, so let's take a look at the definitions of this. Now, for these definitions, here's one of them that is kind of not really there. So this one should be a point. So a point is supposed to be the same thing as a dot. So I don't know why they put dot on here. If it was me that wrote this, I would not have put the word dot. All right, so all you have to do is just look up the definitions for each of these. We've gone over the definitions a whole bunch of times, and if I write this out, then it's going to extend this video a good 15 minutes. All right, so you guys should know these definitions by now, okay? So I'm going to go back over, so I'm going to kind of skip that and go over to number 4. Okay, 4 says, given the figure below, determine the value of x and the measure of each angle. So now that plus that together all have to add up to 180. So it's going to be x plus 4x plus 20 equals 180. So I did that right there. So I add them all together. So together I get 5x plus 20 equals 180 minus 20. So 5x is 160 divided by 5. And then x equals 160 divided by 5. That's going to be 32. X is going to be 32. So I'll verify it. I'll use this calculator here because someone asked me to. So 160 divided by 5 right there, 32. So x is 32. Now, I know what x is, find the angle measures. So I already know what that one is. I don't know what these two are. So if I plug in my 32 for this, my first one's going to be 32, and this one right here is going to be 4 times 32. 4 times x, so it's 4 times 32. So 4 times 32, 128. And if I verify this, all three of those have to add up to 180. So I got my 32 plus 128 plus my 20. There's my 180. So now from right here, they explain the reason behind your equation. So now this is going to be a straight line. So this straight line together equals 180. And that's the reason for that one. Now for this one right here, given the following, find the lengths of TL and TO. So T is the midpoint of XO. So T is the midpoint of XO. So now that's important. So midpoint means it's the middle. And so if it's in the middle of XO, I knew that both those are going to be the same. So I'm going to do the tick marks. I'm using a double tick mark here because a single tick mark was already used for these. Okay, the length of XO is 10. So if all this right here is 10, and so think of it like this. You go get that 10-inch sub, you split it with your friend, and they're equal pieces. Each piece is going to be 5 right there. All right, so we get 5 and 5 there. That's very good. Now, and it says HL is 8. So from H to L, this one is 8. Now, these are single tick marks. So that means that this is congruent to this. Now, congruent means that they are the same measure. So that means that this piece is going to be 8. So now that I have every single segment and I have a value for all of it, it says find TL. So TL, so from T all the way to L. So that's going to be a 5 and an 8, so together that's 13. And T to O. So T to O. So from T to O, which is just this little piece, that one by itself is just 5. Okay, so it takes down to the next one. It says, circle all the following statements that are definitely true about the diagram below. There may be more than one answer. So for this one right here, definitely true. So look at the markings. So I have a marking here, so that means that this marking says that this piece is congruent to this piece. It says that this whole thing adds up to 90. Okay, so let's look. AEB, so it's angle E in between A and B, which I have here, is congruent to DEC. DEC. Okay, that's good because I have markings there. That one already says that they're congruent. Angle AEC, AEC is adjacent to BED. So BED. So I'll show you this right here. AEC, BED. So remember, adjacent share a common vertex and a common side do not overlap. The problem is this one goes from here to here, and this one goes from here to here. So they overlap in this area here. So that means that this one is not going to be. So that one's a no. So for the next one is AEB. So AEB and BEC. So AEB, BEC are complementary. Now, so yes, they are, just because I know that BEC, which is here to here, and CED from here to here have to add up to 90, because that's what this box right here tells me. Okay, the box tells me that those two are 90, but then if this is the same as this, so even though I'm going from here to here this time, going from here to here, so you're just shifting it down the same amount. So if that means if this is, you know, I'm going to put in some values. So let's say this is 30. That's a 0. That means this is 30. And that if this piece right here has to add up to 90, this would be 60. So 30 and 60 add up to 90. So right there, so instead, now this time they're asking for these two right here. These two are going to add up to 90. Okay, so therefore they are complementary. Okay, so they're just trying to trick you on this one. So that's going to be the complementary. DEC. So DEC, DEC plus BEC, BEC equal 90. So again, DEC, BEC, there's my 60 that I had and my 30 that I had. So yes, because that little box right there already tells me that they add up to 90. So that one's true. So EC bisects BED. So BED, EC. Now bisect means cuts it into two equal parts. So we don't really know about the value on this. I gave it a 30 and a 60. Okay, I don't know what the value is. I was just trying to prove that these two pieces and this one right here are the same, and they would add up to 90. Now, there's nothing in here, no markings, no nothing that says that this is going to be the same as this. So bisect means cuts into two equal parts. They're not going to be equal parts. I'm not sure because it's not stated. There's not enough information to say that one. And DEA is supplementary. So DEA is supplementary. Now, supplementary means adds up to 180. Doesn't look like it, but for them to be supplementary, I need to have two angles to add up to 180 for this one right here. So DEA by itself cannot do it, and that does not look like a straight angle. All right, so let's take a look at this next one. Now, on number 6, in the figure below, SP bisects. So now this one says bisect. This is important. So that bisects. So bisect cuts it into 2 equal parts. That means that this piece is going to be congruent to this piece because that bisects RST. If the measure of RSP is 50, what is the measure of PST? So PST. So because of the definition of bisect, I got that these 2 pieces are congruent. So therefore, if this piece is 50, this piece is also 50. And RST, which is asking for the whole thing, is going to be both those together, which is 100. So angle PST equals 50 degrees. Angle RST equals 100 degrees. All right, next one here. So starting our GCO9. GCO9 goes along with the parallel lines cut by transversal. Okay, so now this should be a symbol for parallel. Kind of had that issue with the one I was printing off this. All right, so 3, so M is parallel to N and 3 is congruent to 6. So whenever I'm doing a 2-column proof, I should always start off with my given. So that's given to me. Now, 2 is congruent to 3. So 2 is congruent to 3 right here. I look at their relationship. They're back to back, and together they form an X. So therefore, that one is going to be vertical. So vertical angles are congruent. Okay, if you want to write out the whole thing. All right. And 3 congruent to 6. Angle 3 congruent to angle 6. So now they're both on the inside. So my angle pair relation on this one is going to be alternate interior angles. There we go. All right. Let's take a look at number 8. So on number 8 here we have, okay, here's another parallel one. Nice little box that doesn't show up. All right, so now for this one right here, whenever I'm doing a 2-column proof, I should always start off with my given here. There we go. So prove 3 and 5 are supplementary. Okay, so now I start off with my given. So 1 is congruent to 5. 1 is congruent to 5. Those two, their relationship that they are corresponding. Corresponding angles. Now, 1 is congruent to 5 by corresponding. Measure of angle 1 is congruent to the measure of angle 5. That one right there is going to be the definition of congruent. So I'm just going from the pair relation to the measurement. So definition of congruent. So definition of congruent. 3 and 1 are supplementary. 3 and 1 are supplementary right there. So those are going to be a linear pair. So 3 and 1 are a linear pair. Angle 1 plus angle 3 equals 180. So a supplementary, so now I'm just changing this, so what I have right here, into mathematics. So I'm actually just putting the numbers and symbols in for all this. So that one's, I'm just substituting that. So if they are supplementary, I'm just going to say, you know, for that one, that one's going to be substitution property. Now, this one's going to be 3 and 5 are supplementary. Okay, let's see. 3 and 5 are supplementary. Okay, 3 and 5 are supplementary right here. So, a couple things that I did. So we could actually do different things here. So now, see up here where we said 3 and 1, but now we're saying 3 and 5. So now, if I'm looking right here, because of this one right here, 1 and 5 are the same thing. 1 and 5 are the same. So if 1 and 5 is the same, so I'm just going to replace 1 with 5 right here. So if I'm replacing that, that's going to be substitution. property. And my last one, 1 and 3 are supplementary. Okay, 1 and 3 are supplementary. So that one right there, that one's going to be definition of supplementary. So we start off with this, we are all the way down to here. So, and there's a typo right here. This one we're trying to prove that it's 3 and 5. So this one should say 5, not 1. So sorry about that. So 3 and 5 are supplementary. That's going to be definition of supplementary. There we go. So sorry about the typos. I'm going to make sure there's not one on the test. Double check it. All right. Now, number 9. Number 9, which lines must be parallel based on the given information diagram? Justify your answer. 13 and 12. So let's take a look. 13 is right here. 12 is right here. That means that they're both right here. So they're going on these two lines right here. So the transversal would be D. So transversal is D. So transversal is D, and these two, there are alternate interior angles. Okay, so alternate interior angles. So we have alternate interior angles there, and because of that, I'm going to have lines, the two parallel lines that are on there are going to be lines A and lines B are going to be congruent to each other. So lines A and B, and so because they're alternate interior angles, and now I'm going from that they are congruent, going backwards to say that they're parallel, I would actually say alternate interior angles, and this is the converse. So it's the converse of this one right here. So if we start with that they're congruent, you have to use the converse to go to parallel. If I start with parallel, I go and I would just go straight to down that they're congruent. So kind of working it backwards on this one right here. All right, number 10. All right, 10. Name a pair of each angles following the state property congruent supplementary, all that good stuff. So if they're parallel, and that's what these arrow markings mean. So arrow markings mean that they're parallel, like this. So name a pair of each of the following and state their property. So alternate interior angles. So there's a couple different ones. So it's going to be angle B and H because they're on the inside. Okay, opposite sides of my transversal. And it's also C and E, but I'm only going to write one. So angle B and angle H. Sorry. All right, so same side interior. That means they're both on the inside and they're on the same side. So it's going to be B and E, or it's also C and H. So angle B and angle E. So C and H is also a valid answer. Vertical angles, there's a whole bunch of them here. So I'm just going to use A and C here. So angle A and angle C. So it's what will work is angle A and C, D and B, E and G, or E and F will also work for that one. Alternate exterior angles, so I'm going to go with an A and G, angle A and angle G. So A and G, and also a D and F would also work for that. Corresponding angles, there's another one with a bunch of different ones. So inside, outside, and same side. So this one's the inside, this one's the outside, and they're both on the same side of my transversal. So I'm going to say angle C and G. So there's a whole bunch of different ones. So it's C and G, H and D, B and F, E and A. And this last one for this is a linear pair. That means together they're touching each other, share a common vertex, and add up to 180. So I'm going to go with like an A and a B. So angle A and angle B. So a lot of them work. So AB will work, BC will work, AD will work, EF, FG, or GH, or HE. So all of them work as long as together they're next to each other and they add up to 180. All right, so that's it. Don't forget, like and subscribe. If this helped you, at least let me know that I helped you. I'd appreciate that. All right, thanks. Bye.